Hello. Now we'll do this problem where there is a point mass placed along the x-axis, the location is given, and the distance of this point mass with respect to origin is 4 meter, which is also given. And we apply a force of 10 Newton onto this point mass, make an angle 60 degree with the x-axis. So in this case, we want to calculate how much torque is being applied onto this point mass with respect to the origin. We want to calculate that. So to calculate the torque, if you remember, we are having multiple formulas or single formula and multiple ways. So there is one thing we can go by, which is R cross F. In that case, we need R and F in terms of vector, which we don't have. Or we can go by taking the mod of R and the perpendicular component of F to the R. Then n cap. Or we can take mod of F and the component of R perpendicular to F multiplied with n cap. Either one of the method we can follow. Obviously this we will not follow because the R and this F is not given in terms of I cap, J cap. Okay, we can calculate them in terms of I cap, J cap, but let's go by different method in this case. So in this case you can see what I'll do, I'll go by this one. So in this case, if I want to follow this method, to calculate the torque, I need mod of R, magnitude of R, which I am already having. So to calculate the magnitude of torque, I'll take the mod of R, which is the 4, and I'll multiply it with by perpendicular component of force perpendicular to the R. So you see, this is the force. This is not perpendicular to R. So if this is the R, this is your R, and if you go perpendicular, this is the parallel direction, this is the perpendicular direction. So if I get component of force along this direction, if I get component of this force along this direction, I'll be multiplying it here. You see, this is the force, angle is 60. So obviously the component of force along this direction will be equals to F sine 60, and that will give you 10 multiplied with sine 60, which is root 3 by 2. So we'll put it here. So 10 multiplied with root 3 by 2, and that will give you 20 root 3 Newton into meter. So that becomes your mod of torque. Now we have to get the direction. Okay. So to get the direction, n cap, what we do, we assume this point is fixed. This is the axis, and I'll assume there is a rod. This is like a rod, hypothetical rod, and this point onto the rod, I'll fix it. So if I fix this point, what I'll do, onto this end there is a force which is applied. So onto this end I'll apply the force, and because of this force, what will happen to the rod? It will move like that. So this rod will move anti-clockwise. And if this rod is moving anti-clockwise, and if there is a screw placed here, that screw will come out. And if that screw is coming out, the direction of torque is in the direction of that screw. But the screw has to be in the plane containing R and F, so which is this. So this screw will rotate anti-clockwise, it will come out, and outside direction in this case, if you can see, that is the z-axis, and that I can represent by k cap. So tau will be equals to 20 root 3 k cap, and that too positive. So that will become your torque. So we learn how to calculate the torque using this method. Similarly, this method can also be applied here. Even in this case, I can apply it. So the thing is, if you see, this is the direction of force. So this will be the perpendicular. This is the line perpendicular to the force. So if I can take the component of this R along this, so to get the component, I'll put a perpendicular from here. So all I need to calculate is this length. So force multiplied with this length will give you this value. So let's calculate that. So if I use this method to calculate the torque, it is mod of force and perpendicular component of R perpendicular to the F. So the force is 10. And I need to calculate this line. So this line is perpendicular to the force. This line is perpendicular to the force. So this is 90. This one is 60. So this will become 30. And if this angle is 30, this angle will also be 30. In this triangle, if you see, this is the hypotenuse, this is the perpendicular, this is the base. This is 4. This angle is 30. So this will be equals to 4 cos 30. I'll put the value 4 multiplied with cos 30, and the value of cos 30 is root 3 by 2, and that will again give you 20 root 3. So see, you can follow any method but answer you will get the single answer. Answer will not change, whatever method you want to follow. If you follow the right method, in right manner, you'll get the same result. Okay? Thank you.